Pamela. Pamela's over there. Let me also share Pamela and her beautiful profile picture. I think it's precious. And her topic today is going to be on best practices with Kotlin Multiplatform mobile apps. Do you want to talk about yourself a little bit more, Pamela?
Not really, but
Okay.
if my little puppy Emma manages to wander around, I will definitely pick her up and show her to everyone. I know that's why everyone came to the talk.
But it's definitely
Okay.
a huge bonus.
Yeah, it's definitely like a factor. Okay, I'm going to share my screen and then let's get started. Okay. If someone can confirm that they can see my screen, that would be great.
Yes, we
All
can see
good?
the screen.
Okay. Okay, so hi folks, welcome to my talk, Best Practices for Developing Amazing Kotlin Multiplatform Apps. My name is Pamela, I'm a developer advocate at JetBrains. So perhaps you haven't heard of Kotlin Multiplatform before, or perhaps you're wondering why you should give Kotlin Multiplatform a try. So let's start by just introducing the topic. And let's just talk about what Kotlin Multiplatform is in general. It's an SDK by JetBrains, and it is in beta since October 2022. And it's definitely going stable very, very soon. And it allows development teams to share common code between platforms. Now, I want to highlight these two sections or pieces of the sentence: common code and platforms. What is common code? What can we share? And what platforms are supported by this technology? Well, it's server, mobile, which includes Android and iOS, desktop, which includes Linux, Windows, and macOS, and web, which includes JS and WASM. And so I want to talk about what is common code, what can we actually share. So before Kotlin Multiplatform, whenever your company said, okay, we're going to develop an Android and iOS app, for example, you would always create sort of, and if you were going to use a native approach, you would create your applications very separate. You would still have different layers for the Android application and for the iOS application. So for example, say you had some data and core layers, business and domain layers, presentation layers, and UI layers for the Android app. You would kind of have exactly the same on the iOS side, roughly. But with Kotlin Multiplatform, you are now able to share business logic between Android and iOS and desktop and so on. And so that purple block is your multi-platform module, that shared code that you have. So here is like a scenario that you can actually share your data and core layers and your business and domain layers. And then you can actually write on Android and iOS, you can write your presentation and UI layers natively. But you can take it one step further and also share your presentation layers, your presenters, view models, and controllers. The choice is completely yours. And now you are in the slide, I'm showing how you can share your presentation logic. And you would basically be coding your UIs, your UI layers natively on Android and iOS. So you'd have that nice native look and feel. But with a new technology from JetBrains called Compose Multiplatform, you can also share your UI layer. And the only things that you really doing natively is platform-specific code. And that's not really something that you can share between platforms. That is definitely platform-specific. So how does it actually work? Well, Kotlin Multiplatform compiles your shared module, that Kotlin Multiplatform module, into a platform-specific artifact, which you can then add and use in your apps. So on the left-hand side, we've got our iOS apps, or the iOS side, where the Kotlin native compiler will compile your shared module into framework files or CocoaPods, which you then add and use from your iOS app. Then on the left-hand side for Android, the Kotlin JVM compiler will compile your shared module into jar files or AR files, which you then add and use from your Android app. So what are the benefits of using this approach? Well, firstly, the flexibility to choose what is shared and what is not shared. So if I decide I just want to share one constant or one utility function, or I want to share a feature, or I want to share almost everything, I have that flexibility to choose what is shared and what is not shared. I also can choose to share in a new or existing project. So I don't have to start my project completely from scratch again. If I want to use Kotlin Multiplatform, I can go ahead and use it in my existing projects as well. Because we are sharing code, we are avoiding duplication, and that automatically lowers the effort and cost per feature. But it also ensures consistency amongst the platforms. So if, for example, I have a sales tax constant that I share between Android, iOS, and desktop, maybe server, I can have consistency amongst those platforms on my sales tax constant. And we also have access to platform capabilities without overhead. So I can access my, say, Android APIs without additional overhead. So I'd like to show you a little demo. If you're keen to explore the code, this is where you can find it. It's on my GitHub page, pahill/cmdemo. So I'm going to take you to Android Studio. I hope that you can see it. If you can't see it, please let me know. And I'm just going to move this a little bit up. Great. So the first part of a demo is always the tricky part where you actually show that things are working. So wish me luck. First, we're going to look at the Android app. So I've selected Android app in this run debug configuration, and I'm going to click on run. And there it is. It's run my Android application, and I'm just zooming in. So when I click, there's a Hello World button, and when I click on it, there's a nice little animation, and Hello World changes to Hello Android 33. Now, 33 is the SDK version of the emulator that I'm running this application on. And when I click on the button again, it will sort of animate in and out. Next, I want to show you my desktop version. So there we go. Now, unfortunately, it pops up wherever it wants to, but here's my Hello World, and it says Hello Mac OS X, and it will animate in and out. And iOS is next. Let me just stop the desktop version. And iOS is next. So this sometimes takes a little bit of time, but no, all good. Hello World, hello iOS 17.01. And that is it for the demos. It seems like the odds were in my favor this time. Right, so let's get to the code part for today, where I want to show you just the structure of the application. So we've got a directory here or a module here, Android app, and that's where our Android application lives. iOS app is where our iOS application lives, and this shared module. And inside shared module, there is 4 source sets, and common main is where all our shared code lives. And then there are 3 platform-specific sort of code source sets. One for Android, one for desktop, and one for iOS. And we're going to be looking at common main first into a file called appkt. Let's open that one up. So here we have appkt, and we're looking at the structure of the whole application. This is what the application actually consists of mostly. Of course, there are a few details like how it actually gets in the Android application, but this is basically the application. And so our application consists of a composable function app that wraps some content in a material theme. Now, if you were really paying attention, you would have seen that purple button is the dead giveaway of material, like a default material theme. And then we declare 2 variables. We're declaring greeting text, which is initially a hello world greeting string, and then show image, which is initially false. And we have a vertical structure, a column with a button, a button and an image inside of it. And the button just has some text inside of it initially. So it's greeting text, and initially it will be hello world. But when I do an on-click on that button, some things will change. Greeting text will change to hello get platform name, and we will invert show image. So if it was true, if it was false initially, then it becomes true, and vice versa. We also have a little bit of animation going here with animated visibility on show image, and we just show the image, animate the image going in and out from the top of the screen. So if you were paying attention, you would have seen this hello get platform name. Now I wonder why on different platforms, like on Android and iOS and desktop, they're all saying different things. They're saying hello iOS 17.01, they're saying hello Android 33, they're saying hello Mac OS X. So there's something interesting cooking here. And so let's have a look at get platform name. So here we have just basically a function declaration. So I hope you expect to have fun. We have expect fun, get platform name that returns something of type string, but there's no implementation here. To find the implementation, we actually have to look to these three platform-specific source sets: Android main, desktop main, and iOS main. And you can actually go to the matching the actual implementations of get platform name using this gutter icon for A. And first we're going to look at Android. So here we navigate into it and we see that we have sort of this matching function, get platform name, return something of type string. But it is not marked with expect, it's marked with actual. So expect and actual sort of match each other. And here I'm returning Android and then some Android specific code that is going to give us the SDK version of the device that we're running on. So we're actually accessing Android APIs here. If I want to navigate back from the Android main source set, I can do so with a gutter icon, and I want to show you the desktop next. So here we're actually using, if I hover over here, you can see it's java.lang. And this is basically just, this is Kotlin JVM. So it's, we're basically calling desktop stuff here. And we're using system.get property and then giving it this property OS name. So we're querying it for the operating system name. And this is in the desktop main directory. So here, this will return a completely different value based on what platform you're actually running it on. So if we navigate back and we want to see what's happening in iOS, we can see, interestingly enough, that in the import statements, we are importing platform UIKit UI device. So this means that we're actually querying the iOS APIs for the device that we're currently running on. So we're using some iOS UIKit platform properties and functions to get the system name and system version. And so my main point here is that you can share a lot of code in your common main, but you can do platform-specific stuff using the expect actual mechanism. So I'm going to go back to my site. So once again, if you want to see what I've done here, if you want to snoop on my project, you're most welcome to. It's under PA Hill CM Demo on GitHub. But if you want to sort of do your own thing and use one of our templates, you can do so using jb.gg/compose. And I'm going to quickly show you how you can use that platform. So this is where you get to when you type in that URL. You get to the Compose Multiplatform landing page, and then you can just click on Get Started. And here you are on the Compose Multiplatform GitHub page. And then you have this menu of options, you have like the smorgasbord of options. You can first share code between Android and iOS. So Android is kind of obvious. There's desktop, which is Windows, Mac OS, and Linux, and web, which is WASM. So you can then go ahead and, for example, if I wanted to share code between Android and iOS, I can click on it and navigate up, say use this template, create a new repository, and then I can enter a repository name and click on create repository, and it will use that GitHub template and create a repository for me that I can pull down, play with, and then maybe it's such an awesome repository that I become rich and famous because it's such an amazing app. What do you think? Sounds good? Yes. Right, back to the slideshow. So we've just seen how there are best practices for how there is this mechanism called expect actual, and it's a way to get platform specific behavior into our common code. Now there's some best practices for this mechanism, for this expect actual mechanism. And the first tip that I want to give you is to not use this mechanism if you can. First, check if there's a suitable Kotlin multi-platform library that does the things that you need to do for your use case first. And one way that you can do that is with KMP Awesome, which is just a website. It's a GitHub repository by one of my colleagues, Kostya. And it is really great. It is sort of curated. It's a long list of libraries of it's categorized, and here you can see all the categories. So underneath each category, there is a long list of libraries and a description about what the library is about and how it supports multi-platform and so on. But if you must use the expect actual mechanism, you can go ahead and use functions. So here we have this block, and that is basically our shared module. And inside we have these colored blocks, iOS main, common main, and Android main. And so when we write in common main, when we write expect fun random UID, so we want to create a random UID that returns something of type string. We have to implement for every expect construct, we have to implement in the platform specific source sets. So that's iOS main and Android main. We have to implement that function or construct with an actual behavior. So it would be the same declaration, the same function name, for example, here, and then just proceeded with the actual keyword and also including some behavior, some implementation. So on Android main, we can see that we're using some Java stuff here. And that is true because we can use Kotlin JVM and all kinds of Android APIs in Android main. So here we are implementing random UID with a java.util sort of class and function, UID.random UID, and then we just toString it to get a nice string. On the iOS side, on the left-hand side, you can see that we're importing platform.foundation, and we're using the NSUUID .uid string class and function. And so we're using the iOS APIs here, and we're using the foundation sort of like set of APIs here. Now, something to note that's really important is in common main, you can only have common Kotlin code. So that would be your Kotlin language features and things like the standard lib, and also multi-platform libraries you can use from common main. In Android main, you can use Kotlin JVM, so you can call all the normal Java stuff that you'd like, plus your Android APIs you can call from there. In iOS main, you can use you can use Kotlin native and all kinds of iOS APIs here, but you can never call from iOS main some stuff in Android main or vice versa. And you can also not call from common main stuff in Android main and iOS main. So you can never call Android stuff from common main. You can't access the APIs directly. You have to use the expect actual mechanism to do so. I hope that's clear, but I'll reiterate a little bit later again. So my hot tip number 2 is to use expect actual functions and properties for simple cases and interfaces for more complex cases. So here I'm declaring in common main an interface called platform. So it's kind of emulating what I had in my demo. And it has a property name. So clearly it's going to do something that is platform specific in Android main and iOS main. Maybe it's something to do with like returning Android and the SDK version or something like that. So in Android main, we define a class called Android platform that is implementing that interface platform, and it will have a platform specific implementation that's just not shown here. On iOS main, we're going to have a class called iOS platform that implements platform. And again, it will have a platform specific implementation there. But how do you actually provide this implementation to the rest of your app? Well, firstly, you can have factory functions. So in common main, you can define a function called expect fun, get platform that returns something of type platform. And then in Android main, you can have that actual fun, get platform that returns Android platform. And on iOS side, it would be iOS platform. So it's just it's a factory function providing the platform specific Android platform with the platform class. Then you can also use something like early entry points. So you would define a function called app that takes a parameter called a parameter of type platform, and then you perform all kinds of different app logic on it. So you need to call this app function somewhere in the beginning of your application. So on Android, on the right-hand side, you can see that I'm calling app within the onCreate of my application. And I'm passing in at the Android platform class as a platform instance. And then on the iOS side, here I'm using SwiftUI. And within the init function of my iOS application, I am calling iOS the app function with iOS platform. So instead of passing something like Android platform, I'm passing in iOS platform to do some iOS specific logic. But of course, you should probably use something like dependency injection. And what we just saw is like a vague sort of stab at dependency injection. And you should use a dependency injection framework to provide interface implementation. It has a whole host of benefits, including that it's going to make your application a lot more testable. So you could go ahead and use a framework called Coin. And here in common main, I've defined an expect val platform module of type module. And so on the right-hand side, you can see that I've sort of also have my actual val platform module of type module. And then I use the coin DSL. And the coin DSL basically on the right-hand side is saying that whenever I am injecting something of type platform, please make it, initially have a singleton, and please pass this singleton of Android platform whenever I'm injecting platform. And on the left-hand side for iOS, it's sort of doing the same thing. It's saying whenever you are injecting something of type platform, please return a singleton of type iOS platform. So a question I often get asked is really about, can I use something like Dagger or Hilt for, especially by Android developers? I'm asked this question, especially by Android developers. And the answer is no, you can't use Dagger and Hilt because it is not a multi-platform library. You can use Kotlin or Kotlin Inject. You can also use manual dependency injection if you want to do. Next, I want to talk about coroutines and flows. So coroutines is a topic that's been covered extensively online. And so by now, I'm sure that you know what they are and what they do. But I do want to really focus a little bit more on how to consume them in the Kotlin Multiplatform app. Not so much on Android. I'm going to show you just quickly how it works. But I want to focus more on iOS because that's where the interesting stuff lies. So my demo application is just, you can see on the left-hand side is Android, the right-hand side is iOS, and I'm using native UIs. And so the application is it accesses the SpaceX rocket launch APIs to get the latest rocket launches from this API, from this web service, and then it displays it on the screen. So this is a potentially long-running sort of operation. So we have to mark this getting of the launches, this web service call, as a suspend function. So you can see here, I have marked it. There's this SDK.getLaunches, and that is a suspend function. And if I am using Android with Compose, if I have a Jetpack Compose application, I have to use the launched effect side effect to launch my to basically use that suspend function within my Compose code. And whenever this get launches returns with some values, it will set list rocket launch, which will cause a recomposition for this composable called pull to refresh rocket launches. And that is basically just a composable of like a pull to refresh control and a lazy list of rocket launches. So if you were to pull down the application, if you were to pull it down, there would be a pull to refresh control that sort of pops up, and the rest of the time there would be the list of rocket launches. So on iOS, things are a little bit more tricky, and that is because you don't actually have coroutines and suspend functions aren't actually an Objective-C or Swift concept. So in the Objective-C handler, in the Objective-C headers, there is, it actually gets translated into completion handlers or callbacks. So instead of, in the way that we are used to handling coroutines, we have to use a completion handler now. So here we're calling SDK.getLaunches and we're passing in a completion handler. So the way that this is going to work is that if we get some data, we're going to set a published variable on the Swift side, on the iOS side. And this will sort of be displayed on the UI. And the UI can be one of three states. It can be loading, result, or error. So there might be, it might still be loading some data. It might have a result state with all the rocket launches, or it might be in an error state with some kind of nice description. So if we get some data from our SDK.getLaunches call, we will set our launches published variable to a result enum with the launches data inside of it. But if there's an error, then we will set that published variable to an error. However, this is not a really great approach for two reasons. Firstly, is this actually doesn't really read very well, especially if you start adding more and more suspend functions to your code and they start getting nested. So that is sort of known as callback hell, because it becomes super, super difficult to reason about what is going where, and it starts descending into like this pyramid sort of shape. The other problem that we have here is that it doesn't support cancellation. We're either waiting for a result or we're waiting for a timeout and timeout and subsequent error. And that is a really bad use of system resources. So let's try and find another approach to completion handlers that actually solves these two problems. So my next approach is to use Swift's async await mechanism. And this is from Swift 5.5 from iOS 13 onward. And the first thing that I need to do is to mark my view model as a main actor. Now, this is because Kotlin native requires that whenever you call a suspend function, it must be done on the main thread. This won't block the main thread when you call the get launches, the suspend function on the main thread, because remember, this is a coroutine. It will simply it just needs to be called on that thread. So it will suspend after you've called it. The next thing we do is to wrap our code in a task to support concurrency. And then we use the await keyword to wait for our suspend function results. And then we'll set either the result or the error message there. So the problem with this approach is, it does definitely read a lot better, but the problem is that it doesn't actually support cancellation. So I can actually take that task and assign it to a value or like a constant, and I can say .cancel, but it doesn't actually do anything. It's just the stub. So how do we actually go about providing cancellation support? Well, the next approach that we can use is KMP native Coroutines. It's a plugin and library. It's sort of like a set of plugin and libraries, and it is by Rick Clefas. And so it's an open source library, completely free and really cool. And so the first thing that you need to do is, so you add it to your Gradle, Gradle files, your Gradle build files, and then you have to mark every suspend function that you want to use in this manner with @native coroutines. And then you sort of pair it with the async function library call. So like before, we had to mark our get launches function call with @native coroutines, and now we sort of wrap that inside an async function, and then the rest of it pretty much reads the same. And now we have cancellation support, but remember that @main actor, it's still necessary. My next approach, which is equally cool and amazing, is Sky from TouchLab. And here, what you need to do is you simply have to add a Gradle plugin or a plugin to your Gradle build scripts, and it will just do its magic. So you don't have to add an annotation at, the @native coroutines annotation. It works as before, and the view model pretty much stays the same as what it was in our async await approach. And it is perfectly cancelable, and it will, once again, remember your @main actor. My last topic for tonight is really about flows. So flows is just, instead of a suspend function that only returns one value, we have flows that return a sort of like a sequence of values. So flows, the demo that I want to show you is just the same data as what we had before, but it is sort of more spaced out in terms of time. So what I did was I created a flow by taking the data and just sort of like splitting the list. At first, I just showed the first and the original entry into the web service, and then I showed 2 entries, and then 3 entries, and 4 entries, with the newest always at the top. So let's have a look at that again. You can see 2006, 2007, 2008, and it's also going from unsuccessful to successful, which is pretty cool. And so that is the demo. Now, the problem with flows is related to your Objective-C and Swift interop on iOS. So Objective-C doesn't support generics on protocols. So your flow interfaces lose the generic value type. So what this means is that your flow interfaces are sort of mapped to protocols, and protocols don't have generic value types, so they're lost in this sort of lost in translation. And you also need to support cancellation and have that main thread safety like you did before. Now, the first solution to this is again KMP native coroutines, where you need to where you need to provide your flows. You need to mark your flows with the add native coroutines annotation. And here, instead of having just a sort of fire and forget or fire and get a result, we use instead of async function, we use async sequence. And then we iterate over this sequence that we get back to set the published variable launches with the result data. The next, and of course, main actor is very important. The next solution is again Sky. And so here it takes the approach of translating the flow into an async sequence, which is a Swift concept. And so instead of doing a do, catch, try thing, instead, if you do go ahead and cancel the task, it will simply just stop giving data and will flow through. So instead, we use get launches, which returns a sequence, and then we just iterate over the data in the sequence to set the launches published variable. Now, perhaps you're wondering, how do I choose between KMP native coroutines and Sky? So KMP native coroutines has been around a lot longer. It's a tried and tested solution, and it may be a little bit more stable. And it also supports not just async await, but also the combine and Rx Swift approaches to concurrency, whereas Sky is much less verbose and it doesn't have any wrappers, but it only supports the async await mechanism as far as I'm aware. And it also actually is not just about coroutines and flows. It's actually about improving your whole Swift interop journey. And so you can actually go ahead and use it for, improving your default arguments interop or your enum interop with Swift. And it's a really, really handy tool. Now, something else that I wanted to mention is that it's not an all or nothing approach. It doesn't have to be either or. You can actually use KMP native coroutines with Sky. For example, if you wanted to use the default arguments enum approach from Sky, and then you wanted to use KMP native coroutines to do your suspending functions and flows, that is perfectly doable. You can do it like that. And my call to action is really about trying that jb.gg/compose. Try and see if you can understand how the application is structured. Try and see if you understand the expect actual mechanism and how to sort of try and add a few elements to the UI, maybe more buttons, maybe some text editing things, and then see if you can do some platform specific stuff with your expect actual mechanism. And then you could even take it further, have a look at that repo, that KMP Awesome repo, and see if you can add some multi-platform libraries in your shared code and see what you can call from there. And with that, are there any questions? I'm going to stop sharing.
Yeah, so there's some questions already in the Slack. I don't know if Pamela and Ren, you'd like to kind of go through those?
Shall I start from the top?
Yeah.
Ren, do you want to help me? Do you want to select the questions and then I just answer them?
One person asked initially, Sue asked if you're going to post up the slides.
So I will share the slides within the, if that's okay, if it's okay, I will share that them in the Women of Code mobile Slack. The
Mhm.
reason for it is I'm actually using it again for another conference, and I don't want like the attendees to get the sneak peek beforehand. So I'll
Right.
share them in the Women of Code mobile Slack channels.
Oh, perfect. Yeah, maybe in the general channel. And in that case, let me look for the link to join the mobile Slack, and I'll post it in the chat.
Great. Okay, cool.
Nice. And then we had another question that was about whether the shared or common code actually generates platform-specific code.
I'm not really, let me try and understand this question. Does the shared or common code generate platform-specific code?
Yeah, that was my question.
Mhm.
Yeah, because I guess explaining what I've done some cross-platform in the past, like in Titanium, where you write the code in JavaScript and it'll actually generate Android-specific code, iOS-specific code. So I wasn't sure if that was the same kind of thing happening, or what happens with that common code, I guess.
I think if you remember back in my slides, there was a slide where I had the shared module, and then how it was compiled. That shared module was compiled by different compilers into dependencies, which you then add and use in your app. So I don't know if that makes it a little bit more clear. So your shared or common code are actually going to be compiled into dependencies, which you then add and use from your apps.
Okay, yeah, that's the workflow I'm used to as well. So thanks for clearing that up.
Speaking of workflows, another question you had was about what the recommended workflow is for building a multi-platform app with KMP. Where do you start developing first?
Mm-hmm. So a while back, I saw a very interesting talk by Nate Ebel. I can't remember the company that he works for, but he was talking at DroidCon NYC. It was last year, about brownfield apps. And he was sort of saying, like, they initially just started with a few constants and started sharing a few constants. And then they had a few, they wanted to make sure that they could get it in their CI/CD pipeline, that they could deploy it to production without having sort of errors or bugs or crashes and stuff. So that's how they sort of went about that. The workflow really does depend on like the common workflow. So this is just the getting started workflow. But so it's really up to you, but I would always say, like, just start gently with yourself. And just share a few utility things, or things that are common bugbears that are quite small, like email validation or password validation, things like that. But the workflow really does depend on your team. You could, for example, have both your Android and iOS developers that want to contribute to the code, and they could, for example, decide they all have the whole repository on their machines, and they could build and run just as they would normally. Or your iOS developers might not be keen to try it initially, but maybe a little bit later. And then you have what is called a remote workflow, where you could use something like TouchLab's KMP Bridge, KMM Bridge. It's not KMP Bridge yet. You can use KMM Bridge to actually publish your artifacts as SPM files or as CocoaPods and so on. And then the iOS developers can just sort of consume them. They don't have to have Android Studio and Gradle and all these pieces of software on their machines. They don't have to actually code the Kotlin. And then you can have sort of a blended mode where sometimes it's local and sometimes it's remote, depending on whether you want to get your hands dirty on the code or not.
Nice. All right. So there was another question, some maybe tangential to that. It was about, in an iOS approach 3A and 3B, are you mixing Swift and Kotlin code in the same file?
No, so I'm actually calling Kotlin code from the Swift code. So those were both Swift. So the @native coroutines annotation was on a Kotlin file, and then the next file, the next slide was a Swift code slide.
Okie dokie.
Yeah.
And then Ingrid asked, could we use a Swift package manager instead of CocoaPods?
So the answer is, it is a little bit more nuanced than a yes or a no. So the way that it's currently done is using KMM Bridge from TouchLab, and they enable you to use SBM using your CI/CD pipeline instead of CocoaPods. But there's no way to sort of do it locally at the moment. It's something that is still being worked on.
Okie dokie. So I think we got through it all. Thank you so much. There is a link to the mobile Slack over there. And today has mentioned something really interesting about Louis' question. And yeah.
So something interesting is that Tadeus is one of the authors of Sky, and he is also a very dear friend of mine, and I'm very glad that he's here supporting me today. Thanks, Tadeus.
Oh, that's amazing.
This is how we know so many things about this topic.
So, yeah, we do have a few minutes left. If folks have any more questions, you can also raise your hand if you'd like to speak. We can unmute you if you want to ask your question that way. So yeah, we can wait a minute or so, see if folks have any more questions or thoughts. But thank you so much, Pamela, for this amazing talk. I learned a lot, and thank you everyone for joining. And Ren, thanks for hosting the event. Fantastic job.
Thank you, Louis.